Welcome back. This is an Aleks homework video on calculating the pH of a salt solution. Okay, so a salt, it's a cation and an anion. And that anion could have a hydrogen in front of it. So almost every anion of a salt could be the conjugate base of an acid. And if it is, then it's either the conjugate acid or the conjugate base of a strong acid, which would completely dissociate, or the conjugate base of a weak acid. And if it is a weak acid, then that conjugate base could also act as a base. So the anion of a salt often can receive the hydrogen from water. When you dissolve it in water, it can receive the hydrogen from that water and produce hydroxide. Now it is a weak base, so it's not going to produce lots of hydroxide. It's mostly going to be whatever it started to be, but it can break down a little bit, and after equilibrium, okay, so it's an equilibrium problem again, it can produce a base. Now I hope that made some sense. So what you're doing is you're breaking down that salt, finding out what its anion is, and then assuming that that anion can receive a hydrogen from water, in which case it would make a hydroxide. So in this, I've got this example here. I've got the hypochlorite ion plus water, and it's going to turn it into its conjugate acid plus some hydroxide. So this is producing hydroxide. So you would want a base conjugate. Okay, the case of B. Now, Aleks is rarely nice, and it's not going to give you the case of B. In fact, it's not even going to give you the case of A. It'll give you a case of pKa, and then force you to find everything else. So how do you do that? We know that the case of B is going to be the water constant, which is just a number you can look up, 1.01 times 10 to the negative 14, divided by the case of A. We also know that the case of A, which we don't have, you can find from the pKa. So Aleks certainly did not help us here. He made it as hard as he could, I'm sure, giving us 2 or 3 extra steps, but we can find the case of A that we need in order to find the case of B, and we have to do that from the 10 to the X button on the calculator. So put in the case of A, make it negative, and then hit the 10 to the X button, in which case here we've got our pKa as 7.50, so negative 7.5, 10 to that power, gives you 3.16 times 10 to the negative 8. Put that on the bottom, and you can find your case of B. All right, so now we've got our expression. We've got our conjugate acid times the hydroxide divided by the salt, divided by the anion of the salt, and then that is going to equal case of B. Okay, do you see how complicated this is? I would call this a very hard problem. There's many steps here, and every one of these steps I could blow it. Okay, so you might actually just want to do this problem, look at the video, stop it little by little, and try to do this problem before you go back and do the other one, and then you may be able to do it in one shot, possibly. Okay, now it's equilibrium. So you have to do an ice table just like any equilibrium problem. So here, the hypochlorite is 0.79 molar solution, and it's going to produce the conjugate acid plus the hydroxide. So it's going to go away, producing the X, and so you have 0.79 minus X and X and X. And now we're going to put it in the case of B expression, just like we just worked on it. So when you put that in, it's X squared over 0.79 minus x equals the case of b. And now here's the fudge. Okay, anybody that's been with me over these last videos have seen that I do not like these serious 6 pages of math problems. I fudge. So this x is tiny. It is a very, very small x, because this is the amount of hydroxide being made. Well, it's a weak base, so it's not going to make tons and tons of hydroxide. So I'm simply going to approximate that as 0. Once I do that, my math becomes easier. All I'm doing is taking the square root, multiply 0.79 times k sub b, and take the square root of it. So what I have found here, here's my big long number, is the concentration of hydroxide. Well, I'm interested in the pH, so I want the negative log of the hydronium ion, not the hydroxide. So I need to turn this hydroxide into the hydronium ion, and I do that through the water constant again. So the concentration of hydronium equals the water constant divided by the concentration of the base, which we know. And the water constant we know, it's just you can look it up, 1.01 times 10 to the negative 14 times our concentration of hydroxide gives you our hydronium. Take the negative log of that, and I think they ask to do 1 decimal place. So very involved, lots of steps. I don't know how many steps, 10 steps here. Okay, so I would call this hard, but if you do a little bit of studying, you won't bang your head against the wall. And I wish you good studying.